Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is episode 2 in our series on Martin Fowler's Refactoring. Hey, Matt.
Hey, John.
How are you today?
I'm doing pretty well. I'm excited to talk about Chapter 2 of Refactoring by, I forget this guy's name every single time. Martin something.
Martin Fowler. I always want to say Kent Beck because he quotes Kent Beck, but
it may as well have been written by Kent Beck as far as I can tell.
I mean, Martin Fowler is clearly stealing all of Kent Beck's best material. So
Martin Fowler is just a mouthpiece for Kent Beck, essentially.
Yeah, exactly.
No, that's we don't mean to besmirch Martin Fowler's good name.
No, he's clearly awesome. He's leading the charge on refactoring, which I fully support. I'd be right there. I'd be like a soldier on the battlefield.
In the refactoring army.
So in this chapter, I figured out that I want to be not a great programmer, but just a good programmer with great habits. That's what I figured out.
Well, this clarifies so much of my programming history.
Oh, history.
Or just like my experience with programming, where I identify strongly with what Martin Fowler is saying. Because what he says in the book is he's not a great debugger. Like some people, to quote him, some people can just look at a block of code and see the bugs.
Yeah.
And he says he can't do that. And I identify with that. Some people I work with, you say an approach, and they're like, bing, 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 bing. These are all the cases where that's going to fail. Like, this is this race condition that code has, and that has never been the way my brain operates.
Oh, yeah, me neither. I think those people are very rare.
Well, I don't know. I work with a bunch of them, so.
Yeah. Well, I feel like we've always worked at companies where there's just, smart people everywhere, just coming out of the woodwork.
Right. But the problem up until this point is I don't think I've had the great habits that I'm going to acquire by reading the refactoring book.
Yeah.
But to get back on track, this chapter is called Principles in Refactoring. And I think Martin Fowler is using this chapter as a way to essentially preach about why you should refactor and why you should consider using this as a very kind of precisely defined tool.
Yeah. I almost feel like the theme of this chapter was this is why refactoring is the umbrella term that encompasses all of these good code practices. Because I felt like the chapter was just this series of kind of well-known, I would say fairly well-known, good code practices, you ain't gonna need it, for instance. And it was kind of refactoring kind of encompasses this, and if your team is doing extreme programming and refactoring all the time, this is a policy that it'll be easier for you to kind of stick with. And I thought that was interesting.
Yeah. I think I agree with what you said, and I think it's probably in part because of this book, but at Google, both of us worked at Google, a lot of these policies are just kind of ingrained in the culture of software development at Google, right? He talks about having a code base with not very stringent ACLs, control schemes where only one person can make a change to the code.
Yes.
Right? Google, one repo, one massive monorepo. And what I've seen, and this is the thing, when you work at Google, you see these code base wide refactors that get sent across, and they get chopped up into tiny code reviews that are sent out to, the late listed owners. But one person can essentially make a code base wide refactor for all of Google.
Right. Yeah.
And I think that pays a lot of long-term dividends for Google. To Martin Fowler's credit, the ability to continuously make these small refactors that increase the health of the code base is just allowing Google to continue to, deliver high quality software.
Yeah. He talked about a lot of kind of repo management techniques that I just very much identify with. Like, he talked about like trunk-based development.
Yes.
Which is something that more and more I just increasingly believe in. And I guess I'll explain what this means. A lot of companies or team cultures do this thing where they'll develop a feature on a branch. So they might be working on a feature for like months, and it won't actually be in the repository. And then there's like, some day or period where they're merging that entire feature into the repository, and then they like release the feature into the world. Well, trunk-based development is sort of this concept where you don't do this branch work, or if you are using branches, it lives for a very short period, and you merge it into trunk basically as quickly as you can. Like as soon as you have something that's not like completely broken, I guess, merge it into trunk. And and this is just something that I have found is just way better for everything. Way better for catching bugs earlier. Way better for developing features because you don't have to do this massive merge, which is a very error-prone process.
Yeah.
Way better for the customer in the end because the feature is sort of incrementally being developed. People are catching things earlier. People do better development practices like feature flags because feature flags is kind of a necessity of this type of development. So this is just something where the minute I saw that in this chapter, I was like, yes, because I just believe if code is not in trunk, it has very little value.
Right.
And that's just a policy that I've always abided by.
This is interesting because I feel like this process where you switch from this very feature branch heavy development cycle to doing everything on trunk, that must have happened before I really started to work in the industry because, well, I guess I just started at Google, and Google does not do that at all. There's really no, in very few cases are there is there any like a concept of a branch?
Yeah, right.
And certainly not a branch that more than one developer can work on. Or like would be checking commits to. So,
I've worked at places where you maintain branches. That was just kind of the way people did things. Facebook actually did that a little bit. I mean, they were pretty good about, it was kind of an unwritten rule to like merge as quickly as possible. But generally, you'd start like a tag and kind of work on stuff on that tag. And then my first company also used branches a lot, although I didn't because I was like young and didn't understand how branches worked. So
maybe that was a good thing that you got used to not working on branches.
Yeah, I just remember everyone talking about like, oh yeah, I got this feature branch, and I'd be like, oh, I don't understand Git because I was like 22.
But the long and the short of it though is that I don't know what it's like. I don't have anything to compare it to because my current company, when we were working together, there was never a branch. Everyone was just working on it. Everyone was just literally working directly on master.
I would just be submitting like straight up compilation errors.
Yes. But that's the beauty of working with two engineers. You don't need to worry about it because you just talk. There's one other person who could have caused your problem.
Yeah. Well, that's another thing I believe is like small simpatico teams are so much more effective than like larger teams that sort of struggle to coordinate. I guess that's a fairly well-known thing, but that's something I believe in.
I had a question. How do you think we did? What do you think Martin Fowler would think of the Math Chops code base?
Oh boy.
Or the development process?
I mean, I actually think we did pretty good. Like, I think we work super well together.
Mm-hmm.
I think we fixed stuff design wise. We refactored stuff when we thought code was like super ugly, or if we came up with like a different way of doing stuff that we thought was better. I think we went back and kind of replaced things. I guess there were periods where we like killed features and we kind of didn't completely delete the feature, which is kind of gross. One thing I like he mentioned in the chapter that I thought like we could have done better at, I certainly could have done better at, is he just mentioned like team code ownership, and you kind of alluded to this as well, where like everyone on the team is literally touching everything. You know, like if someone commits something, someone else could literally see that code the next day and be like, oh, I think this is a better name for this function. Or like, oh, I've seen a better way of doing this, you know, processing. I'm gonna just change your code. I love that. Like my personal feelings about my own code is like, I don't want to have any ownership. Like once I put it into the repo, like I want the team to own it and to like, if anyone thinks they can improve it, like please do.
Yeah.
And I've seen this on teams where kind of individuals have strong ownership over like big parts of the code. And there's kind of this feeling of like, you know, like people just don't touch each other's code. And I think an ideal team is one where that doesn't exist, where it's just kind of like everyone feels totally fine, like touching each other's stuff and kind of doing slight improvements. Because I might be good at certain things, but like my teammates are better at things that I'm kind of bad at, and like I want their help on my stuff. So
yeah, especially when it comes to there's a production issue in some that's related to one of these places where there's like this very strong ownership by one person, and everyone else is like kind of shrugs and is like,
yeah,
I don't really know. I don't know how that feature works, you know, because I don't really touch that code because Jim Stevens owns it. So
yeah,
you have to talk to Jim, who's on holiday for 2 weeks.
Siloization. It's the you know, the bane of projects.
Well, it's interesting though, because just recently I had an engineer that I worked with who actually came out kind of and advocated for silos, like, and kind of was like, yeah, I know. That was my initial response, you know, for the listeners. John had a look of disgust upon his face, and so, but I think potentially, like, you can't have, like, as you grow, you can't have everybody all working on the code has to develop some of these structures. And I think his thesis was that it's just really important that those boundaries are well defined, you know, and it's like those interfaces are like, we're just being explicit about where those boundaries are and who owns what and what have you, and designing it in such a way that, well, basically, he said we should just kind of like lean into silos, but do it in an intentional way.
Yeah, I mean, I don't disagree with that. I think that's probably not the way that I would word it. I mean, I think that, yes, parts of the code base, you know, services need to be owned by teams. And that's just, I feel like if something goes wrong in a service, like there needs to be a clear person that you can reach out to. And if you need to build a feature in a service, there needs to be like a set of people that can build that feature. But what I think is that like within that service and within that team, there needs to be shared ownership. So yeah, I don't think I'm advocating for like this kind of like utterly
structureless.
Yeah, like I was trying to think of like, you know, what would that be, like anarchy? Like I was trying to think of the society type where just like kind of everyone's doing everything, but yeah, I'm not advocating for that. I think ownership is a very important concept in software development, but I think like individual ownership of large components is bad, very bad.
Yeah.
And I'm sure that guy, I think the guy at your work would probably agree with that. But yeah, I think the word silo is maybe loaded, because I do think that if you're using the word silo to mean entire teams owning services, then I agree with that.
Yeah. There's a video, there's a talk where someone talks about, I don't know if it was advanced patterns. We'll add it in the show notes. And but one of the patterns that he talks about is, I think he called it shallow silos, which, like, obviously naturally team members are going to develop some expertise on some parts of the code base, but you should try to fight that person being the only one who knows about, so it's like, yes, you will allow some specialization in the code base, but you also don't want to let that go too far.
The next thing I wanted to chat about was this concept of preparatory refactoring, which I read this other book a long time ago that I really liked by, I think it was Ken Pugh, and it's called Prefactoring. And the premise of the book was all of these different practices that you can enact that will kind of make your code more resilient and less in need of refactoring in the future. And a lot of them were things like Yagni, or I remember splitters can be lumpers, but lumpers can't be splitters, which basically refers to, I think, a true concept in software development that if you're thinking of, creating like two separate like interfaces or something to handle a job versus like one big interface to handle the job, you should probably create the two interfaces. Because it's much easier later on down the road to like combine those than it is to like take one big thing and split it into two things. But anyway, it was just a bunch of these little rules to make your code a little bit more resilient and less likely to need refactoring. I thought that was an interesting concept.
There's this part that he talks about speculative flexibility. And it kind of gets to what you were talking about with Yagni, where, like, don't try to assume the ways in which your code is going to need to grow. Make a simple implementation of it first, and then, and this is where it breaks down a little bit for me, but he basically just like, well, just, you should have flexibility in like your ability to change how the code is factored in such a way that you can have it accommodate anything. But I feel like that's like a little bit pie in the sky. I don't know. Like, I feel like sometimes you make some decisions that just make certain kinds of changes really difficult, and especially anything to do with like the way that the data is modeled. Like, you have all of this this momentum where there's all of this existing data, and you need to make sure you really understand the domain of possible values so you can kind of migrate it into this new format. Like, and maybe this isn't what he's talking about. He's talking about structuring the code itself and not the model. And maybe that's a whole nother book, like model refactoring versus like code refactoring.
Oh man. He did mention database refactoring, which I wanted to chat about because I thought we have some experience there, and I thought that what we built was amazing, that like DCR process. So, but yeah, I think like, and correct me if I'm wrong or if this wasn't how you sort of understood that, but I feel like a lot of what he's talking about is like valuing code flexibility over a lot of things, basically. Code, there's kind of this big like web of attributes that code can have. And I think a lot of people value like design, for instance, where it's like, oh, is there like a 5-page design document for this component? That's a valuable thing. I completely disagree with that. I think that, Martin Fowler might say one of the most important attributes of code is that it's flexible. It's easy to change. It doesn't have like a ton of clients depending on these APIs that make it harder to change. Try to keep client lifetime as short as possible so that you can deprecate things. And that's sort of how I've read into a lot of his points. And that might just be my personal leanings sort of creeping out, because I'm a huge proponent of like code flexibility over a lot of different things. But yeah, that was how I read into that concept. I can't remember what it was called, the prospective refactoring or whatever.
I think there's kind of two flexibilities that we're kind of alluding to here, where there's flexibility where you write this very flexible architecture, this pluggable architecture or something, and then you won't need to change the architecture, and you can kind of just like, it can just be whatever you need it to be, and then you just have to write like modules for the pluggable architecture or something. But then, like, I think he would say, well, it doesn't make, like, trying to build that flexible, like, platform up front is the wrong thing to do, because, like, you could totally envision the problem domain changing in a way that the flexibility that this architecture affords is not valuable, because you need it to change in a way that in which it's not flexible.
Yeah.
And so, like, I think his thesis is that you should build this, kind of the simplest thing that solves the problem. And then again, like to what you were saying, like the code base should have the flexibility so that it can be expanded to accommodate those things. Not necessarily that you have this godly abstraction that then never needs to change.
Oh, yeah. Yeah. I think that's pretty well put. That actually leads to something, kind of a philosophical question I wanted to throw out.
Yeah.
And this is just the importance of design. I'll just throw out my own potentially controversial opinion. I think design is very overrated in the world of software. I think, like, there's so many teams that I've been on that, like, literally every change to a piece of software requires a design doc, and it requires like a bunch of stakeholders to get into a room and kind of nod their heads. And I think processes like that are kind of like bad for software development. I mean, obviously that incurs a lot of like time overhead, but I think it also incurs a lot of other types of overhead that a lot of people don't think about. Like, people feel more hesitant to just make random little changes, or if people see something, they might not fix it because they're like, oh, do I need to kind of write a design doc in order to fix this? And I'm not saying that I don't believe in design, because I think obviously it's important for engineers to share opinions and at least get other people to look at their opinions and kind of concur or to like find flaws. But I just think that pretty much every culture I've been a part of that believes strongly in like design, I have found the designs to be too much and kind of over the top.
Interesting. Yeah, I think I've seen this where you add friction to the process of making every change, and like there's going to be fewer changes, and I think maybe that's a bad thing. Maybe you want to encourage these changes. It's hard because I think you do want this process for a more junior developer putting out their ideas, getting feedback from more senior developers.
Yeah.
And I think potentially when you have a company as big as Google, like you wind up needing to formalize that process, because you wind up with some people, maybe you hire 100 employees and most of them are pretty good about like, hey, like, this is what I'm thinking. Is that a reasonable approach? The team lead says, sure, like go in that direction. But then maybe you get an engineer who kind of is like going cowboy, and like they're working in the corner for a while and not really telling anyone like what their bigger plan is. And then everyone gets in a room and they're like, well, this could have been avoided if we had kind of talked about this big picture design.
Right. Yeah, no, that's totally true. Totally true. There's certainly downsides to like individuals kind of lone wolfing it. But this does actually lead to another interesting thing that I've found is avoiding mistakes. I think so many processes in software are put in place to avoid mistakes, which is good. I think avoiding mistakes is super important, but I think almost more important is putting in place processes to recover from mistakes.
Yeah.
And I think obviously mistakes are just going to happen. So you kind of have to ask yourself the question, do I want to block changes and kind of make sure mistakes don't happen? Or do I want changes to kind of flow freely and just make sure that we recover very quickly from mistakes and mistakes are mitigated as quickly as possible? And I actually believe in, the latter. I think it's super important for changes to kind of free flow, super important for people to be able to get their code in the code base. But when that exists, you need to be able to recover as quickly as possible and fix mistakes.
Yeah, I think you and Martin Fowler would be aligned on that. Getting back to your earlier point about design, I mean, he eschews classic big design up front, and that it's you're not going to get it right with this beautiful 100-page design specification.
Never.
I think up until now I've kind of fallen into this trap that it's designs are discrete, and it's you need to immediately move from, and obviously this is not the case, but it's you need to kind of immediately move from design A to design B. You do this big reworking of the code. I forget exactly what the terminology he uses, but he defines it in contrast to refactoring. I think maybe he calls it restructuring. But in my frame of reference, I just need to kind of atomically move from design A to design B. What I really like, or what I find is kind of a powerful idea from what he provides, is he's no, there's a million steps along the way from design A to design B.
Yeah.
And it's you just keep on taking those steps, and eventually you're going to get there. And actually, I think that's a really interesting point that he puts out to discuss, because I feel my fear would be you start on this journey of 1,000 steps to design B, but it's you leave the team, or you stop doing that. Someone else isn't really aware of what you're doing. Because all of this refactoring that he alludes to is all happening implicitly, as far as I can tell. It's not he's talking to someone else about this is this big refactoring that I'm doing 1,000 steps at a time, or one step at a time. And so it feels you could wind up in a situation where you have these two paradigms that you haven't refactored all the old way you're doing it yet. It's half and half, and you're kind of in this local minimum on the journey from design A to design B. And I just wonder what he would say about that.
Oh, interesting. So you're saying getting from A to B, you're often in these stages where it's actually worse than A or B.
Right.
Yeah. Yeah, and that's actually a super interesting point, where a lot of refactorings, one obvious example is where you're kind of rebuilding a part of the system, where you have two things that are existing at the same time. You haven't migrated production traffic over to the new thing, so you're kind of maintaining these two things, and that's obviously a huge cost on an organization. And yeah, he doesn't talk about that very much. He says to try to avoid that as much as possible, but you can't sometimes.
Well, especially given the way that he outlines to do refactorings, I feel that's. He says that these refactorings might take weeks, might take, months or weeks or whatever. I forget, but so clearly along the way, in, month 2 of 3, you're going to be in this intermediary state. So for example, in Math Chops, in our back end, we use observables all over the place in ways that are probably kind of stupid, frankly. I don't think we we
avoided promises like the plague for no reason.
Well, yeah, we just kind of we said observables everywhere. Yeah. in kind of like, I don't know, just an overly broad, like we don't want to need to make the decision of whether it needs to be a promise or an observable. So just everything's an observable, which is just clearly kind of an absurd thing to do in retrospect.
Yeah.
But so like, let's say the refactoring is to start using promises, right? In places. We realize the error of our ways. We're like, okay, we want to start to use promises. So now I'm assuming that the thousands of steps, are updating all of the different API calls to, to use the new paradigm. But like halfway through, let's say, I don't know, I get distracted. I'm doing something else. I leave the team. So now you're in a state where if someone else comes in and looks at the code, like it's completely non-obvious like what the rule is.
Right.
Because half of the things are using observables and half of them are using promises. And you're like, what's the right thing to do here? Like, I don't even know.
Yeah.
And then, so like, again, I'd just be curious what he would say about that. Like, is the thing just like, don't stop halfway?
Yeah, and maybe it's kind of the team, any refactoring that's substantial is something that the whole team needs to know about and kind of be behind, and so someone else, like I guess he does say a couple times that like multiple members of a team can contribute to like a refactor at the same time.
Yeah,
especially something like that where it's like, oh, let's get rid of all occurrences of this one thing and eventually replace them all with this other thing. Like if everyone in the team knows about it, they can kind of use the Boy Scout principle and like replace stuff as they see it.
Yeah.
But that is an interesting, and this is something that organizations have so much trouble with is large refactors and kind of proving the value of a large refactor. And it's just so hard to make that decision because you're always dealing with this hypothetical universe where the refactor is complete and everything is glorious. But in order to get to that hypothetical universe, it's going to take 6 months, of engineer time, which is very, very expensive to a company. So it's just, it's just hard to make that decision.
I think the author would say, well, you're never going to arrive there. It's always this process that's going on. Because like he says, it's like, I wrote a feature well for, I wrote the system well for feature A, and then feature B comes along, and then now feature A is kind of poorly, or like the way I built feature A is poorly factored for supporting feature A and feature B.
Right.
So I think, I think it's a fallacy to think in terms of like, oh, we're going to get into this like beautiful state of the world and like where everything is going to, because like new things are going to happen along the way that are going to mean that like, it's never going to be completely, perfectly factored.
Yeah. It's hard to build a narrative out of that, I think. Like if you're, say you're trying to sell a huge refactor to an entire organization, it's just, I think it's difficult to build that narrative of like, oh, here's the million steps that we're going to take. And, maybe each step has like a pros and cons analysis. I think it's easier. It's easier if there is some like light at the end of the tunnel where you can call out like, oh, here's the end state. But I do agree. I think as an engineer, you have to understand all those incremental stages and know what the pros and cons of each incremental stage are, and you need to be able to deliver them in a timely fashion because organizations aren't going to wait 6 months for some mega change to the code base. Like they're going to want to see value every step of the way. So it's tricky.
So maybe this won't make it into the podcast, but word on the street is you're currently in the process of working on some similar sort of refactoring. So I'm curious if reading this book is affecting the way you're thinking about how you're going to go about, like, are you thinking maybe you should think through these tiny operations at a more granular level?
Yeah, I think there's a ton of value in that. At least being able to just vocalize to other engineers, especially like, here's the incremental steps, here's how quickly we'll reach those incremental steps, and this is the value they'll provide. But I do think that when you're talking to like, CEO level people or VP level people, you need to build a narrative. And for a large refactor, a refactor that's going to take a year potentially, it's such a complex thing, but you need to build a simple narrative that kind of, and it can't, I'm not saying that you oversimplify it. Like you need to know exactly what the kind of end state is and why it's going to be very, very beneficial to the organization. So it is this kind of interesting process. At least what I found is it's this interesting process where you really do need to understand every step of the way so that you can kind of sell these incremental steps to smaller parts of your organization. But you also need to understand this much larger sort of sea change and be able to build a really compelling narrative out of that as well. So it's tricky. I mean, I think, I'm a huge proponent of refactoring, but it can just be difficult to sell to people just because you're talking about a hypothetical world that doesn't exist yet.
Right. All right. Well, I think that was the most. I think there's actually a ton in this chapter. It was a lot. The chapter was quite a bit longer than I realized, and I felt like it was a little bit repetitive. Like I felt like I was like, did I read this section already? Because he's kind of saying the same things a little bit, but just kind of like framing it in a different way.
Yeah.
But
yeah, not the best chapter. I'm excited for him to get into kind of, like the next chapter is on code smells. And I'm just excited about that. I want to see those, his opinions on like what are bad practices.
Right. But I think the other thing I want to do is really try to do as a programming exercise. Maybe pull the code that he had in that first chapter, like last chapter. We went through an example, and just do the steps. Go through just so I can really feel what it's like to make those steps. But I've definitely been trying in my day-to-day to like intentionally make a change, get the code to, a small change, get the code to build, and then kind of continue on. And I think it's a useful exercise, even if I don't wind up like doing that full time or like do quite as small steps as Martin does.
I agree. I want to do that more. And I did love how he, the first steps that he was taking was to break all the code into like its individual atoms, like the individual data blocks and the individual functions, which even in object-oriented programming, like those are the atoms of the program.
Yes.
And then he sort of like structured those into molecules. I thought that was really cool.
All right.
Awesome.
I think that's it. Well, tune in next week for Chapter 3.
Code smells.
Code smells. All right.
All right, Matt. I'll see you later.
See you later.